Good morning and good afternoon, everyone. How are you today? This is January 2022, which is exciting. And welcome to the January Indoor Ag Science Café. I'm Cherry Kubota. I'm a professor at The Ohio State University. I am part of the project team OptimIA, which is focusing on leafy green production under fully controlled environment. Participating universities are Michigan State University, the Ohio State University, Purdue University, and University of Arizona. So let's start cafe. So this is a list of upcoming one. Today is a very special one. It's an indoor farming technology showcase, but the rest of the schedules are all in OptimIA website. So please check out the date, title, and then also presenter good things coming up. So today it's a unique effort we are doing. It's a technology showcase, having 4 presenters from industry, Fluence, CO2 GRO, water harvesting, Unfold Bio, talking about their technologies. And then so you have opportunity to listen. And then if you are technology providers sitting in this space, you know, member of the cafe and interested in participating next series of indoor farming technology showcase, please let me know so that we can schedule another one in the near future. So with that quick introduction, I'd like to stop my screen share and then wanted to have the first presenter, Brian Poel from Fluence, showing off your technology.
Great. Good morning. You can see my screen and my pointer. Excellent. So thank you for the introduction. I am Brian Poel. I'm a research project manager at Fluence. So essentially, I oversee our internal research projects. We've got our lab that I'm going to touch on briefly. I also head up a lot of our internal cannabis research at our commercial grower partner just outside of Austin, Texas. And then I help kind of coordinate some university and governmental experiments. So I work with a lot of people on the call here today as well. So as part of the technology overview, I just want to give a quick update on our photobiology and research lab. So this is an area we would have introduced this a little bit, maybe at an NCERA meeting in the past. But we really took 2020 to upgrade our facilities in terms of environmental control. That was the main thing that needed to be addressed. So we've got these, they're essentially walk-in fridges, but using the Argus control system, we're able to really tightly control temperature, humidity, CO2, and then we've got kind of top of the line lighting coming out of our custom hardware division. And so we've essentially got 8 grow chambers. They're all technically walk-ins, but we've got 2 in the back that, you know, we can fully walk in. We've got shelves on each side. And then we've got some smaller, you know, technically walk in, but maybe treat them more as reach-in chambers. So here's kind of a layout of what this looks like here. So this is one of the smaller ones. We've got the Phytofy, the Osram Phytofy units set up in one where we can essentially run lots of different lighting experiments. And then we've got, you know, this is a 100% red Viper here. So we're able to run some pretty, you know, high powered. These are obviously dimmed down for our lettuce, but we've got an access to all different spectra, all different technology. And then kind of what I've done here is using our Array 44, we've essentially created a multi-channel fixture. We're just building the whole roof out of lights. So we can essentially get all sorts of different intensities and spectra. So we can, you know, essentially build new spectra and get an idea of how plants will act both in terms of yield and morphology under that. So that's a brief introduction on our lab. Now I'll go to the technology overview. You can find all of this stuff on our website at fluence.science. So on the website, you know, we've got all of the different technology. We've got all of our case studies. We've got previous webinars. So there's all kinds of information. So anything I present here today, you're going to be able to find on the website as well. So this is a screenshot pulled straight from our website. You can click all these and learn more. So this is kind of an overview of what we've got going on right now. I'll touch on First off, we've got our array. I'm sure if I look at the participants here, I know there's a lot of people who have these either for growing or for research. They're still available. They are kind of the workhorse. Even internally with research, like I said, with all of the new products we have, the array is reliable. It's got a range of different spectra, and that's kind of what we use. But as we're migrating to the Razor series, it's essentially a modular system of bars that can be set up in all different configurations. You'll see them on Danish trolleys that you can kind of just slot into. We can get custom spectra on those as well, so we can look at all sorts of different things. But what I really want to touch on is the Viper and the new spectra that we rolled out a couple of years ago. So most people, I mean, maybe it's changed now, but when you think Fluence, a lot of times you might think of a broad spectrum solution. We had a really, I guess, a bit of a revolutionary undertaking going back to lights with higher red content. So these are our spectra options. We have them named for their red content. So R4, R6, R8, and R9B, essentially 40 up to 90% red. So the idea being, we've got our R4, historically named PhysioSpec Indoor. But what we're looking at, and I remember Bruce did a really good presentation, or sorry, Bruce Bugby did a really good presentation for a Glaze webinar late last year, talking about balancing essentially color rendering and efficacy. So as you increase your red, you're obviously increasing your efficacy, but you're reducing your color rendering. However, whether you're in a greenhouse or the color of the light environment doesn't necessarily matter. There's a push-pull in terms of operational efficacy and yield and all sorts of things. And we've got specific recommendations for a few crops that we've done webinars in the past, but it's not as simple as one size fits all. There's different spectra that are optimal for different crops, and even for instance in tomato, within that segment, different cultivars respond differently to different spectra. So moving back to the layout, we also have vine. So this is an intercanopy crop, and it's available in two of those spectra, R6 and R9B. Again, that balance of efficacy and color rendering. And we're going to have some webinars and some content come out this year based on ICL distribution. So where's the best place to put your light as far as top lighting or ICL? And then what's the ideal spectra for that ICL? So that's something we are working on as well. Now, moving over to the right, we've got our Spider series. This is a high-powered light for indoor growing. And what we've come out with, or we're rolling out this year, is a higher powered Spider. So it's almost an 800-watt power supply. The idea to kind of target your canopy at 1,500 micromoles and above. So this is specifically targeting indoor cannabis. And so why 1,500 micromoles? So a lot of the experiments I was doing in 2020 was looking at light intensity on cannabis and how high can we go. You've got a specific canopy size and the idea of targeting, trying to get as much yield as possible out of that. So we went from 1,100 up to 1,500 micromoles, and we did see that continuing, 1% more light equals 1% more yield. We even pushed beyond that up to 2,500 micromoles. And we kind of found, in terms of balancing environment, a range of cultivars, kind of 1,500 is the target to shoot for now. So 1,500 micromoles, if you think of however many years ago, going from, when I started doing horticultural lighting research, we were looking at below 100 micromoles supplemental. Now up to 1,500 and above indoors is really high. But it's all been, vetted through our internal research. And then moving back to the list again, one thing that might seem not as revolutionary, but has actually been very, very, it has been a big deal in terms of my research and working with partners as well, is this shift light scheduler. So it's essentially a digital dimmer. You may remember or I'm sure a lot of people have seen these dimmers as well. Again, workhorse gets the job done. You can, dial in your light intensity. If you're looking at different intensity or balancing a couple of different spectra, works super well for dialing in your intensity. What the key features on this new shift dimmer is photo period control. So you can now turn your lights off and on using the dimmer, which is a big deal. You know, essentially this light, you could set your intensity, but you'd have to find whether it's a timer or controlling the lights on and off with your greenhouse control or your environmental control system. Whereas this kind of supersedes that. You can turn the lights off and on. You can set photo acclimation both during the day, so you can ramp up your light intensity or ramp down at the end of the photo period. So not only on a daily or on a 24-hour period, but also you can set a schedule so you can ramp up or photo acclimate your crop. So we have a lot of people using it for research to turn their lights on and off, whether it's in a greenhouse or in an indoor system, as well as the photo acclimation. So for instance, if you're growing cannabis, you can set a schedule. So when you switch to flower, you can not right away blast the lights with, again, 1500 micromoles. You can ramp them up so that you're taking advantage of every photon that is hitting the crop. And that's through that scheduling. So you can set up a 2-week ramp up and get that granular if you're really interested. So that covers pretty much what's available now. There's always new stuff coming down. Part of research is development, so it's very exciting to see what kind of new things we're working on. So like I said, everything you can find on the website at fluence.science. You can also contact me for any questions on those and older things or newer things or anything else. I'll drop that in the chat as well. It's quite the long tag at the end there, but I'll take questions too.
Right. Thank you, Brian. We have a couple of minutes for questions. Anyone? So I have a quick question. So it's always impressive to see how cannabis plants respond to light intensity. And then wondering if you have a chance to actually start seeing saturation. Yeah,
I didn't include the slide, but we did start to see saturation. We actually had a treatment of a DLI, like a daily light integral of 100. Which essentially worked out to around 2,300 micromoles.
Wow.
As an instantaneous intensity. So it's kind of getting to be brighter than the sun, and yes. we did start to see saturation. And so, like I said, integrating everything sort of operating environment, it starts to level off around 1,800, but 1,500, is kind of maybe more the economical saturation point. For the cultivars we were looking at.
So those plants are grown in when you look at the saturation point, those plants are grown under like high intensity, right?
That's right. Yeah.
Yeah. It's already acclimated. Yeah.
Yeah, yield saturation, not necessarily photosynthesis or anything like that.
Mm. Okay, quick question from Miguel. What were the CO2 levels used? I guess it's relative to that saturation.
Yeah, sure. And we just had a presentation on high intensity cannabis. I can put a link.
The link. Yeah, that'd be great.
Yeah, I'll find the link and I'll put it in the chat as soon as I'm done sharing. But environmental CO2 would have been 1,100 under dark period, under the light period.
Mm. Okay, anyone else? Lighting question to Brian? Product question, Brian? Scientific question?
I have one
quick one, if you don't mind.
Yeah, go ahead.
Sure. Chanel Gordon from AeroFarm. So, Brian, have you performed any photo acclimation experiments on any crops or developed protocols? Because this is something that, without a technology like yours, it's almost been impossible to do, really.
Yeah.
So do you have any kind of data that you can publicly share?
So we don't have as much on photo acclimation. That's something that I would love to, that's something that I've got on my roadmap for 2022. That's 2022. Is looking at that, because it is such a small portion of the whole, for instance, let's say with cannabis, it's such a small portion of the whole crop cycle to dedicate, a whole grow cycle to, let's say, a week of photo acclimation with a couple of different treatments. It's a big investment. Whereas it might be something where, starting with a high intensity doesn't necessarily hurt the plant, but it could be wasted photons. So it could be, something nuanced like that, where you'd be saving money essentially on lighting by photo acclimating, not necessarily setting your plants off better. But that's strictly just a hypothetical. It's something we're definitely going to look at. And then we can look at that for other crops as well.
All right, great. Thank you, Brian. I think it's time, so you can stop sharing.
Great.
Thank you so much.
Yep.
And then make sure you share the link of your
Will do.
presentation.
Yeah.
So the next presenter, so we learned like a little bit, right? The next presenter is about CO2. So the Dil Vashi from CO2 GRO. Dil.
All right, super. All right, so thank you for having us in your Indoor Ag Science Café, especially the first one where you're presenting commercial technologies. I'm Dil Vashi, Corporate Development Manager at CO2 GRO Inc. And we're a Canadian company that's dedicated to enhancing plant growth and productivity in a sustainable manner while helping our grower customers reduce their ecological footprint. And we do this using our patented CO2 delivery solutions technology. So the benefits of CO2 enrichment are widely known and have been known for many decades. And the primary benefits are, of course, accelerated photosynthesis, faster plant growth, and increased plant production. The rule of thumb typically is about 30% more yield if you can increase your CO2 availability to your plants. With respect to our technology, we're actually able to help many growers double their profit margins. So not just increase their yield by 30%, but also increase their profits by up to 100% more. Now, CO2 traditionally has been a limiting factor to growth. As we know, you can control light, you can control water, nutrients, temperature, and so forth, but often CO2 is something which is difficult to maintain in higher levels. Our technology helps to turn that limiting factor now into a strength that you don't have to worry about in the future anymore. So just to give you a sense of how CO2 enrichment has been done traditionally, in sealed facilities, you can pump CO2 gas into the room and maintain levels up to 1500 ppm. Some growers go down as low as 800 ppm, but sort of the rule of thumb is around 1000 to 1200 ppm. However, when you're pumping CO2 gas into a room, you're having to fill up the entire room. And that's what you see here as the blue dots. However, most of the CO2 that's in the room doesn't actually go into the plants. It's only the CO2 that's around those plants, which in this case is depicted by the yellow dots. However, with many grows, both indoor and greenhouses, when they begin venting or exchanging air, a lot of that CO2 is lost and escapes, in which case you're having suboptimal CO2 levels around ambient, which is 400 ppm. Some growers are able to get up to 600 ppm, but it's not that 1000 to 1500 level that they really want to get to, which of course means less CO2 gas available for the plants. So how do we enrich CO2 in a venting structure or in an open type of protected grow? That's where our technology comes into play, and it works in two parts basically. Part one is our CO2 infusion system, which dissolves CO2 gas into water, and it's done at atmospheric pressure. It's not a high pressure type system like your soda stream, for example. We completely dissolve the CO2 gas into water, and it's a bubble-less solution. We then take that dissolved CO2 solution and mist it onto the plants to create a microfilm on the leaf surface. And that microfilm is really where the magic happens. So traditionally, CO2 will take in, plants will take in CO2 through their stomata, which are the tiny pores on the underside of the leaf as they take in the air. However, with our system, we're misting to create a microfilm on the entire top of the leaf surface. And what happens is that microfilm creates a diffusion gradient where you have high concentration of CO2 in the film, lower concentration in the leaf, and that gas that's in that microfilm tends to then transfer into the leaf through tiny cracks in the cuticle. So the cuticle protects the leaf from water getting in, but those tiny microscopic cracks enable that CO2 that's in the solution to diffuse into the leaf. And what this means is because the CO2 is being transported in those droplets, it doesn't escape your grow area, whether it's through venting or air exchange. So you can provide CO2 to your plants year round, regardless whether you're in the summer or the winter. It's a truly green solution. So we're able to reduce CO2 gas loss to the atmosphere, so you're not adding to your carbon footprint. Air quality for workers is improved, so you can maintain the air levels of CO2 at ambient while still providing more CO2 for your plants. Reduces pesticide and herbicide use, and I'll touch on that a little bit later. And it's safe for plants, people, or animals to ingest. So if you decide to take a cup of the solution and drink it, it's not going to be harmful to you. You probably get more CO2 in your Coca-Cola than you do in the solution. So we're able to reduce growers' CO2 enrichment emissions and help their resources be more efficient, so they're not wasting as much in terms of land and water and other cultivation resources. It has a very low operating cost. So again, because we're not filling rooms with CO2 and we're directing the CO2 in that concentrated solution to the plants, you don't require those massive CO2 tanks that you'll typically see outside greenhouses or indoor grows. We're going now to smaller cylinders and micro tanks. So to give you a sense of a tomato greenhouse in a 1 hectare facility, they would normally be using up to 50,000 pounds. So a 20-ton bulk tank a month, versus with our system, you're down to below 5,000 pounds. So you can have a micro bulk tank, which are roughly 750 to 1,000 pounds, filled up every week. So you're saving on footprint, saving on gas, and saving on cost. So with a 30% more yield and a low operating cost, for some growers who have low margins, 10 to 20% gross margins, we can actually increase those gross margins by 10 to 20 points, in effect, increasing their profits by almost double. And we can provide our system to any protected grow. So whether it's high tunnel, simple net house, shade houses, more advanced indoor farms or indoor grows, hoop houses, and of course, greenhouses. Now, we don't apply a lot of solution. We don't get your plant wet or drenched. We apply just enough mist for a few seconds, 2 to 3 times an hour, sometimes up to 4, to where you're creating this microfilm. Visibly, you'll only see tiny droplets on the leaf, and usually those droplets dry off in 5 minutes. Now, one concern that growers have is, regardless of how much mist you might be applying, they're concerned of pathogens, especially things like molds and mildews and bacteria. This is where the system actually helps suppress those, and it's as a result of pH fluctuations. So the dissolved CO2 solution typically has a pH of about 2 points lower than your normal water. So every time we're misting onto the leaf, you're causing the pH on that leaf surface to drop. And once the CO2 diffuses into the plant, which is usually 30 seconds to about a minute, the pH goes back to normal. So this fluctuation of pH drop, normal pH drop, normal throughout the day makes for an environment that's unfavorable for these pathogens to replicate and spread. And CO2 gassing or atmospheric enrichment alone does not provide this type of benefit. This is just a lab paddle study where we did it on E. coli for a visual. You can see on the left, we infected these paddles, if you will, with a few drops of E. coli. Misted it with our dissolved solution. There was barely any spread. We were able to suppress the development of E. coli by up to 99%, versus in a gassed or ambient conditions, you can see the red dots spread like wildfire. In terms of yield impact, we're able to provide as much CO2 to the plant that's required to maximize growth. So versus ambient conditions on peppers, we did bench scale studies where we saw 20% more pepper fruit production and 10% faster growth, which is similar to what you would get if you're able to gas and maintain, and that word maintain is important, about 1200 ppm of atmospheric CO2. Of course, with venting and high air exchange, it's difficult to maintain those levels of gassing, which is where our technology is able to provide that additional CO2 and additional growth. We've done similar projects on scale, where we took a greenhouse in El Salvador, where we misted half of a hectare with our dissolved solution, half of a hectare versus ambient, and we saw what we would expect, a 20% yield improvement. These are just some quick pictures of a misting system, low pressure misting system in a pepper greenhouse on the left and a tomato greenhouse on the right. We're able to position the nozzles in such a way that the mist basically falls down using gravity to cover both the top to bottom of even taller vine crops like tomatoes. This is one in a strawberry greenhouse. On the left, you see hydroponic benches of strawberry. You can see the fog falling onto the leaves. On the right is a strawberry greenhouse on benches grown in pots. This is another example of a lettuce hydroponic greenhouse. The top left is our infusion system. So the infuser itself sits inside a water reservoir. and then using pumps and regulators and so on to create the solution. We then pump the solution out to the misters. And in this case, you can see this trial was done on hydroponic grown lettuce indoor, or in a greenhouse rather. We've seen similar results on kale, where we've seen over 30% biomass increase versus ambient conditions. C4 orchids, which normally take in CO2 during the night, but in this case, we misted it during the day. So it was able to photosynthesize that CO2 on demand, if you will. And we saw 30% faster flowering to maturity, which for orchid growers is a very big deal, a slow growing, high demand plant. More flower production, better rooting, as you would expect, with more carbon available to the plant. And while we're a Canadian-based company and fairly young in our journey, we do have quite a global reach in over a dozen countries now in North America, South America, Central America, Europe, the Middle East, Southern Africa, and also the Far East in Japan and Malaysia. And that's the end of the presentation. You can find more information on our website, co2delivery.ca, and feel free to email me with any questions you have or give me a call. Number and email is there, and I'll put it in the chat as well.
Great. Thank you. So there are several questions. Basically, people wondering about the impact of the humidity in the growing area. Another question was the droplet size of the spray.
Yeah, I can address the droplet size. It's basically low pressure fogging. So you're looking at droplets of around 50 to 100 micron. You might have noticed, a lot of greenhouse growers might notice the Netafim CoolNet Pro foggers that we use. That's a popular brand. We have other brands as well that deliver the same type of pressure and droplets also.
Okay, maybe you can answer the questions in the chat areas.
Yeah, I'll do that.
So that would be great. I have a burning question to you. Do you know the dissolved CO2 concentration with your technology in your water?
Yeah, we typically get to saturation, so about 1.5 grams per liter of water.
Okay. Okay. And then normal concentration in the ambient level, is that proportional maybe? That's the rule, right? Yeah. So if ambient is 400 parts per million, I guess
right.
you are injecting pure CO2.
Yeah, we're taking CO2 typically from know, gas tank, frac air, air liquide. Those
all right.
those
okay, thank you. We need to move on. Thank you so much. All right, so the next presenter is Chris K from water harvesting. So we are gonna talk about water.
Hi, Sherry. Thanks a lot. My name is Chris K. I'm the COO of Water Harvesting. Water Harvesting started as an atmospheric water generation company, started by Professor Omar Yaghi, professor of chemistry at UC Berkeley, created an entire field of chemistry called reticular chemistry. It's a material science, created a number of different materials, one of them being a metal organic framework. And so our product is a use of that metal organic framework, not for drinking water, because we realized about a year ago that we could actually have the most efficient dehumidifier in the world. And so we went from creating drinking water, which we can still do, to focus on disrupting the HVAC industry and doing that by efficient separation of latent or humidity from sensible heat or temperature, which will generate much lower CapEx and OpEx for all HVAC. And for us, our goal is CEA we believe is our lead market, but we believe we're going to grow into the overall HVAC market. And our overall value proposition for HVAC is to reduce global electric demand by 2% and greenhouse gas emissions by over 1 gigaton per year. But for CEA, they're much more modest, and that we believe we can reduce HVAC OpEx by up to 90%. And HVAC CapEx by up to 80%, while at the same time enabling you to precisely control your climate at any VPD level. So how do we do that? We do that by dehumidifying by two things: dehumidifying the air without subcooling, and by removing 6 times the amount of humidity per volume of air. So we use the unique properties of our MOF, or metal organic framework, which has a very sharp isotherm, so it picks up water very fast and releases it very fast as a desiccant. We also have created a generation engine, MOF regeneration engine, that we can basically regenerate the MOF at very low energy cost, much lower than any other dry desiccant. We use the energy between the adsorption and desorption, or if we're quote returning water, if we're generating water and quote returning it, and a number of our customers have called it water recovery. So we dehumidify and we recover that water. So balance those two processes together. And we condition air only to the set point. So if incoming air is at 77 degrees, it leaves our MOF at 77 degrees. You only need to cool it down to 75 if that's your set point. Eliminates defrosting, and byproduct is pure water. I live in Colorado. Our lab is in California. I like to say that you can run our product in Colorado during fire season. You can run it in California during fire season, or anytime in other parts of the world that have heavily polluted environments, and you only have absolutely pure water. So here's an example from one of the farms that we've been talking to. So one of the large farms. This is, we've separated their cost into what they spend on sensible, what they spend on latent, how much they spend on airflow, and then total. And so right now they're spending 1.88 kilowatt hours per liter of water. If we just basically cut a hole in their airflow and put in our MOF modules. And by the way, a way to visualize what a MOF module would look like, it's not exactly right, but if you think of what an electrostatic air filter is, and plates, we put those in. They're not electrically charged, but air flows over the MOF, and the water vapor in the air is attracted to the MOF and gets adsorbed onto the MOF. So just by doing that, you can reduce sensible cost tremendously. We don't change anything. We can basically not change anything else and provide a significant saving. Because we can capture 6 times the amount of water, you have the opportunity to reduce airflow cost, which also then reduces the amount of sensible energy you require, for a very impressive savings. And then finally, if you have a greenfield examples in a hot and humid climate, or a hot and dry climate, or a cold climate, you can attach our dehumidifier with an upgraded AC unit, a unit that would only process sensible heat, or an indirect evaporative cooler in hot and dry climates, or air-to-air heat exchanger for very strong reductions in OpEx. And because of the reduction in, or the improved amount of water we can take out per air volume, we can greatly reduce the amount of HVAC equipment required to process air. So here's an example of the competitive example using comparing our product versus Quest dehumidifiers. We talked to the Chief Innovation Officer for Quest and his team. These numbers basically right there under their logo come from them about what their performance is, kilowatt hours per liter. Here's what our production machine will be. Our current prototype runs at 0.3 kilowatt hours per liter. So you can see already that in mainline applications, we're already significantly less. And then for specialty dehumidification requirements, substantially less. So what makes the MOF unique? It's several things. One, it's a combination of high water capacity, basically can adsorb about 50% of its weight in water, low energy demand. We actually use heat much less than 100 degrees C to desorb them off, fast capture and relief, so we can cycle it very fast, and it's very stable. We cycled it many tens of thousands of times with no degradation of performance. It enables a very efficient refrigeration process. It separates, don't think of it as a filter, but as a separator. Separates H2O from any other component in an airstream. We can tune them off to any specific environmental condition. It's non-toxic, it's 100% recyclable, and it's scalable, available, and economical. Our MOF regeneration engine basically works such as the following, in that you have MOF modules that are in an airstream. Once they get fully adsorbed, they get put into our sealed desorption chamber. In our sealed desorption chamber, heats up the MOF, creates steam. That steam is then pulled into the condensation chamber. That condensation chamber then cools down the steam and collects it into a chamber and then returns it to the farm. And finally, we're one of our small units, our countertop unit, is on display at the Futures exhibit in the Smithsonian. So it makes 4 liters of water per day, and excited about that. It'll be there through July, so go see it. If you have any questions, here's my email address, and thank you very much.
Well, thank you so much. I know humidity is a huge issue in indoor farming. So anyone wanted to ask a question to Chris? What is the largest capacity unit you have? Nadia, you're welcome to use microphone too.
Oh, thank you, Nadia. So the largest unit we've envisioned is just really just a placeholder that we feel that in an ISO container size unit, which 20-foot ISO container, shipping container, we can dehumidify 20,000 liters per day. There's nothing to say that we can't make it larger than that, but that gives you an idea of what the size of a large scale unit would be. And you can put multiples of those together.
So that means you can put this technology in a large space, like largest indoor farming is operating?
Well, that's correct. I mean, we have clients who said that they're currently doing over 10,000 gallons per day, and that they're designing farms that will do 100,000, 200,000 gallons a day. So you could just put, say, multiples of these ISO containers, or it's nothing that says we can't make them bigger. And we don't intend to make those all just one massive machine. We're going to build, quote, modular units and basically combine those together into a large machine.
Great. So somebody wanted to have a contact information. Maybe you can type in.
I'll put that into the chat.
Yeah. What would be the approximate weight of that unit? Is another question.
I don't know. I have it, but I don't know it off the top of my head. Happy to answer that later.
Yeah, maybe you can.
I'll put that in the chat.
Yeah, communicate separately or something like that. So
sure.
All right. Anyone else? You can use microphone if you wish to do so. I have a couple more minutes if you want to ask questions. No, trying to digest, I think. So Chris, I think this technology was originally developed for very different application, right?
Yeah, it was developed for drinking water. Professor Yagi, Palestinian by birth, grew up in Jordan. His family, he says he remembers his family waiting on a water truck every 2 weeks. It's a very big passion of his to provide water to underserved populations in water-starved areas. Actually, our solution is great at doing that. And in fact, the same solution that we would deliver to a vertical farm, to a CEA facility, is in essence, with a difference in which MOF we would use, would be the same solution we would use for drinking water. So we have MOFs that work well in desert conditions, MOFs that work well better in humid environments. And so basically it's which environment we find ourselves in, which MOF we'd put it in. And then for drinking water, actually, because the water is so pure, our first letter of intent was from a German biotech company for sterile water for injection. So for drinking water, we actually have to mineralize the water. So, and our water requires no filtration whatsoever, because it comes right out of the MOF as very pure water.
Yeah, great. Well, thank you so much, Chris. I really appreciate it. So don't forget to put your contact information in the chat.